Okay, so in this exercise we are going to multiply strings together. So the way that this is going to work is that we are going to be given numbers, but they're going to be represented as strings, and we need to find the product. But it says you must not use any built-in big integer library or convert the inputs to integer directly. And I guess this is like one sort of like minor thing that bugs me about some of these exercises is that you have to sort of like figure out what is the proper interpretation. By the way, just looking here, there's no other special stipulations or anything. Because it's like, okay, so if you have num1 equals 1, 2, 3, then what this is saying is that you couldn't just like convert this, let's say that this is a string. You can't just call like, you can't just do int num1 to convert it to an integer. But could you take this string 1, 2, 3 and break it into, just sort of separate out the first digit. So we would have 1. And we would have 23. These would both be strings. And then you could, well, now you're not working with the original string anymore, so now you can call the integer function to convert these to integers. So you can convert this 23 to an integer, and for 1, you could count, okay, so this 1 was the third digit, so let's multiply it by 100 to get the digits correct. And so these are two now integers, and then you can just add the integers together to get 1, 2, 3. Okay, and then you do the same thing for num2, and you multiply the results, and there you go. So I guess with the way the problem is stated, it doesn't technically say that that's not allowed, but it seems like it does go against the spirit of the problem. And so if we think about like what the problem probably wants us to do, it probably wants you to deal with the digits individually. So instead of converting like 1, 2, 3 to an integer, you could convert 1 to an integer, and you could then convert 2 to an integer, same thing with 3, and then move on from there, blah, blah, blah. Okay, so let's go through and figure out how to solve this problem. So let's just think a little bit about how we multiply numbers in general. And so this is going to be a little bit on the simpler side, so feel free to skip ahead. But if we like remember how we multiply integers, so like 6 times 3 is 18, so we could write 18 here. That's multiplying these two. Then 6 times 2 is 12. And so we would write 12 here, but because the 2 is in the second digit, we would move it over. So we would write 12. You could also write 120 directly here if you wanted to fill in all those zeros. Okay, then 6 and 1, this would give you 6. And it would be over here because it's the third digit. And you could fill in the zeros if you want. Then you could keep going. 5 by 3 is 15. 5 times 2 is 10. 5 times 1 is 5. And again here, so we're putting this 5 here because the 1 is in the third digit and the 5 is in the second digit. So it would go, am I doing this right? Yeah, because the 15 would go here and the 10 would go here. And so the 5, if this were like 5 times 2 and this were giving us 10, it would be 1 over more. Okay, so it goes here. Yeah, and duh, because 50 times 100 is going to be 5,000. So yeah. And then, let's see here, the last one, 3 times 4 is 12. This would be all the way over here, because that's 3 times 400 is 1,200. 400 times 20 is 8,000. 400 times 100, that would be, the 4 would be over here, right? Yeah, because 100, 4 times 400, yeah, okay. Cool. And then you just add these all together. So, okay. All right, I didn't need to go through all those details, but the point here is that like what we do for each of these steps is, so like let's take here for example, this, what would be a good example to use? Let's use this one actually, yeah, because this is going to be 1, 2, 3, 1, 2. So this was 50 times 20. So this would be, we have the 2 digits, and we're multiplying them together. So the first digit, that's going to be 20 times 50, and this will give us 1,000. I'll just write it like this, 1,000. And like another way, so this would be 2 times 10 squared, no, just 2 times 10. And this would be 5 times 10. Okay, so basically all we do here is we take, and so because this is 5 times 10, or 2 times 10 times 5 times 10, that gives us 2 times 5, which is another 10, times, okay, so let's write this out. This will give us 2 times 5 times 10 times 10. So this is going to be 10 times 100. Or another way to write this is going to be, because we're basically doing 2 times 5 times 10 to the 1 times 10 to the 1. So this will give us 2 times 5 times 10 to the 2. And the reason I'm going through this is that this is basically how we're going to break these things down. Because what we do is we take the 2 digits and we take where they occur within the numbers. So it's the digit 2, and it's the second digit, and it's the number 5, and it's the second digit. And because they're the second digits, it's 2 times 10 to the 1. Because if you're looking at the nth digit of the number, then to get to that digit, you would do 10 to the power of n minus 1. That's why, so here we need to multiply by 10, which is 10 to the power of 1, which is 10 to the power of 2 minus 1. And the 2 there comes from the fact that this is a second digit. Okay, so what we do is we multiply the 2 like individual digits together, and then we multiply the result by 10 to the power of the sum of those exponents here. And that's basically how we're going to write this script. And that's how we're going to write this at this, the first iteration, and we'll sort of see how this does. But basically, we're going to start with our result is going to be 0. And then we're going to loop through all of the digits. And so the way I'm going to do this is, hold on. Okay. So let me write this out. So what we need to do is we need to figure out like what we're going to be doing is we're going to be looping through like all of the digits in num1 and all the digits in num2. So for the index and digit, for the indices and digits in num1, and for the indices and digits in num2, basically what we need to do is we need to take the result and we need to add, first we can convert the digits into integers and multiply them together. I don't know why I'm pluralizing these. But yeah, so we multiply these together, and then we need to multiply this by 10 to the proper exponent. Okay, and I'm actually going to do this so that we can like write this on multiple lines. I'm not sure what the best way to do this is. Yeah. Okay, sure. We'll do it like this. And so what is this exponent going to be? Well, like we said, we have to, we can figure out, going back to our example here, how do we find the exponent? So here, if we just look at num1, for the final digit 3, this is the final, this occurs at index 2 in the string, because again, Python indices start at 0, so this will be index 1, index 0, index 1, index 2. Okay, so for 3, the number 3, the index in the string is 2, and here let's actually write this out for like 1, 2, 3. We'll do the digit. We'll do the index, and we'll do the exponent of 10 that we need to multiply by the digit to get the corresponding number. So for 3 here, this is at index 2, and if you were to break out this digit here, this would just be associated with the number 3. So that's 3 times 10 to the power of 0, because it's just 3 by itself. You don't need to add any more zeros. So the exponent of 10 here would be 0. Then moving on to digit 2, the index is 1 because, again, 0, 1. And the exponent of 10, okay, well, the digit 2 corresponds to the number 20 if you were to break this out and look at this digit, just considering at which digit it occurs within the number or within the string. And so to get from 2 to 20, we would need to multiply by 10. So that's 10 to the power of 1, so the exponent would be 1. Then finally, the final digit that starts at the beginning of the string would be 0. The digit is 1, the index is 0, and then the exponent of 10 is, well, to get from 1 to 100, you need to multiply by 100, and that's 10 squared, so the exponent is 2. Okay, so how do we get from the index to the exponent? And I'll just call the index I and the exponent E. So if we know, okay, well, there goes my pen. So we're going to need to figure out what exponents we want to use given the indices, because as we're going through our code here, we know what the indices are. We know where these digits are occurring within the string, but we need to get the proper exponent. Okay, so how do we get E from I? So if we can see what the pattern is here, it's just going in like like numerical order, but it's going in as the indices start at 0 and go upwards, the exponents go downwards, and that's because these string representations. In the string representations of the integers, the least significant digits occur at the very right. So the digits at the rightmost digits are going to have the smallest exponents. Okay. So then how would we get? So we know that we're like decreasing by 1, but where do we start? The very first value, the exponent is going to be equal to, well, we had to multiply by 100. And we see here there are 3 digits in this number. And so to get to 100, we do 10 to the power of 2, which is the number of digits minus 1. So let's suppose n is the length of num1. So this is the total number of digits. Then the exponent for the ith digit in the string is going to be, we take n, so we are for sure going to take n, and we are going to have to subtract 1. So this would be for index 0. And then as the indices increase, the exponents decrease at the same rate. So we would also have to subtract I. Okay, and we can see that this works. So like for digit 1, the for the digit 1, for index 0, the exponent is going to be 3 minus 1 minus 0, which is 2. And then continuing up, for index 1, the exponent is going to be, we take that 3 and we subtract 1 to just get us started, and then we subtract another 1 to move us over to the next digit. And that's why we get 1, and going on from there. Okay, so this is going to be our formula for getting the exponent based on the index of the digit we're looking at and the length of the number that we're starting with. Okay, so now we're going to need that for both num1 and for both the first digit and the second digit, because we see here what we do is we multiply the digits together, but then we also multiply those two. We multiply these two things together as well. And the way that we get that is we take those powers of 10 and we add them together. Because we're just multiplying 10 to the first 10 to the first exponent times 10 to the second exponent, and that's just equal to 10 to the power of the first exponent plus the exponent, plus the second exponent. Okay, so we need to get the first and the second exponents, and so we can get them from these numbers. So the exponent for the first digit I suppose this could be like digit 1 exponent, but let's just call it num1 exponent. So we're going to have to take the total number of digits and subtract the index that we're at, and then subtract 1, which is exactly the formula we had here, except I put the -1 at the end. Now, you saw me typing at the beginning here something else here, and that's because the way that this code is written now, we have to evaluate the length of num1 every time we step into this loop. And so we're going to evaluate it like multiple times. And we don't need to do that. We can just evaluate it once at the beginning and store that value and use that value later. And so what we're going to do is we're going to, up here, do num1 digit count. This is going to be the total number of digits in num1, and that's just the length of num1. And then we can use this here instead. And then similarly for num2, we can do num2 digit count. It's the length of num2. And here, num2 exponent will be num2 digit count minus num2 index minus 1. Okay. And so now when we take this result, we're going to multiply the two digits together and then multiply by 10 to the power of, remember, we need to add those exponents. So it would be num1 exponent plus num2 exponent. Right? And then at the end of that, we need to return the result. But here the result is an integer, and the result needs to also be represented as a string. And so we will convert it to a string and return it. Okay, so let's just make sure that I didn't do any bugs. Okay, no bugs, and let's submit it. Okay, and so we see that this solves the exercise. The one thing here is that we see it is a little bit slow. And not only that, but again, I was talking about like what's required for this problem. I think this would be acceptable, but you could think like, okay, well, we are converting it from an integer to a string here, so maybe we could just construct the result using strings instead. And it turns out this approach is doing it in this way, with constructing the result like just using strings and not having it as an integer, actually ends up being more efficient. And part of the reason for that is when we have the result as a number, we have to do this multiplying by 10 to this exponent. And this actually adds in a lot of computation here. I mean, like for a human doing this, like this isn't really complicated, and so that's why it seems simple. But like in a computer, there is still like space that's being taken up to do this computation and do all these multiplications. And so if we think about what really we're doing here, the reason that we're multiplying by 10 is to get the digits to be in the right place within the result. So basically, to take the value that we're getting here by multiplying the two digits together and making sure that the product of the digits is in the correct digit within the result. And we could handle this more efficiently if we were storing the digits of the results separately. And if we were to just able to like access those digits by indexing them, rather than having to multiply by 10 to large powers. So that's what we're going to explore in our second solution. And let's see, given the time that we are at right now, I'm going to stop this video here and then make a second video showing a more efficient solution. And we'll see how much we are able to improve the performance.